Okay, you're on the back of the worksheet now, and this is bringing up stuff from last semester that we need to start reviewing for our finals. So let's take a peek and see if you remember any of this. The first term is kind of already simplified to its most, so I'm just going to rewrite it, 6x to the fifth y. And the second term has a power of 3. So I'm going to write that out. This was called expanded form 3 times, so you can visualize what's going on here with the back. And then I'll talk about the shortcut we learned and see which one you prefer. Okay, so I really have a 6 that's multiplying by 2 times 2 times 2. So 6 times 2 is 12, times 2 is 24, times 2 is 48. I just multiplied all the coefficients together. Big number 6, 2, 2, 2. This is called grouping. Next, I see the x's. And when I'm multiplying a base of x to a certain power, I'm basically just going to add all of these exponents up. So x squared, 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 and to the fifth. So 5 plus 2 is 7, plus 2 is 9, plus 2. So this is like adding all these exponents. So 5 plus 2 is 7, plus 2 is 9, plus 2 is 11. Do you see where we got that? And then finally, the y's are going to do the same thing. Over here, there's a little bit of a trick. This has an invisible 1. Don't forget about that invisible 1. But so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm getting y to the 10th. And that's going 1 plus 3 plus 3 plus 3. Okay, so how'd you do? Did that all make sense? Do you remember doing these? Now, the shortcut I was talking about is where we did the shower of the power. So if it makes more sense to you to go like this, 2 to the third, x to the 2 times 3 is 6, and y to the 3 times 3, which is 9. So this would become 2 to the third, x to the 6th, y to the 9th. And so that's called showering the power. And then you would just multiply this front term by that. Would you rather do that little shortcut, or do you like the expanded form? It's up to you. Okay, on this next one, treat everything separately. Let's first just look at the 15 and the 20. What can divide into that fraction to reduce it? You got it. A 5 goes into 15, a 5 goes into 20. So 15 divided by 5, 3. 20 divided by 5, 4. So far, I've got a 3/4. Next, separately, we look at these x's. I've got 9 x's on the top and 7 x's on the bottom. Do you remember what we do with that? Well, the shortcut was the subtract rule, right? 9 minus 7 is just x squared. There are more x's on the top, so I'm going to have x squared left over on top. Expanded form is where we wrote out all the x's, 9 of them, and all the x's, 7 of them, and they all crossed out except for 2. So if you want to do that expanded form, if you want to do the shortcut, it's up to you. Last but not least, we look at those y's. Notice there's more y's on the bottom. How many more? So 10 minus 13 is y to the negative 3, and negative exponents go downstairs. You should have been left over with 3 on the bottom. How'd you do on that guy? Is this all coming back to you? It's coming up on your final. All right, this next one is in radical form. Remember Tehani's way? Well, this was Tia's way. So I'm trying to simplify this, but I've got 2 separate things going on. So do we want to put them all together first and then simplify it? It's up to you. I've got 18 times 54, which can now go in the same house. I've got x squared and x to the third, which all can go in the same house. And then I've got y and y to the third. And we're taking a square root, which means we're going to be looking for groups of 2. So let's break this all up if you want. 18 and 54, let's break that down. 18 could be 3 times 6, but 6 is 3 times 2. So 3 times 3, 9 times 2, 18. There's the numbers for my 18. Now let's do 54. 54 is 6 times 9. Let's break that down. 6, 2 times 3, 9, 3 times 3. Ooh, I broke down that 18 and that 54 into its smallest parts. Next, I've got x squared and x to the third. So I've got a total of 5 x's. Next, I've got y and y to the third. So I've got a total of those. What am I looking for here? I'm looking for groups of 2. A group of 2, a 3 can come out. Another group of 2, a 2 can come out. A group of 3, another 3 can come out. See that little 3 over there? No pair, so it has to stay. A group of x, Another group of x means we're going to have x squared out here and 1x left over inside. Finally, a group of y's. Another group of y's, I'm going to have y squared out here, and since all the y's got used up, there's none left inside. My final answer here, these numbers out front are all going to multiply. 3 times 2 is 6, times 3 is 18, and then x squared, y squared, square root of 3x. Do you remember those? Coming up on your final. Last one over here has a root 45 on the bottom, so a couple things are going to happen here. Leave the 27 alone for a second. Couldn't I break up the root 45 into square root of 9 and square root of 5? And then these cancel out. What is the square root of 9? Yeah, it's just 3. And what is 27 divided by 3? It's just 9. So how'd you do on that note? There was like a couple tricks there that you needed. But it wasn't that bad. Okay, this next one, what do we know about this picture? This x is equal to right there by vertical angles, and then the x plus 72 adds up to 180 because of same side interior angles being supplementary. All right, what's 180 minus 72? I'm getting 108. So remember, we're putting an answer and a reason for each one. Next one is exterior angle theorem. And that exterior angle is equal to the sum of the remote interiors. 87 minus 15 gives us 72 degrees. Next one is, I guess we could do Pythagorean. X squared for my first leg, root 5 squared for my second leg, and 9 squared for my hypotenuse. We're trying to solve for x. Well, the square root of anything squared like that, that's just going to be 5. So root 5 squared is just 5. It's like it cancels out the radical. And then minusing 5 from both sides. So that's going to be 76, which means you have two different options to do this. But I'd probably prefer you just grab a calculator at this point and take the square root of 76. Please make sure you do that right now and make sure you know how to do it. So I'm getting x is approximately 8.72 u for units because that's a distance. How'd you do? All these are degrees, and this is u for units. Okay, this next one has parallel lines. When we have parallel lines on a picture like that, it's kind of like the homework from a couple nights ago, it means this is a mid-segment. Okay, well, if I've got a 134 over here, then I could do linear pair to get this angle right here. So 180 minus 134 gives me 46. So that means over here is a 46. And that means that x is equal to 46 by corresponding angles are equal. Because when we have parallel lines, we have corresponding angles that are equal. Now, if that's a 46 right here, right here, and this is a 90, couldn't I do triangle sum theorem to get this guy right here? So I could do 46 plus 90 plus, I don't know what I want to call this down here. I guess I'll just call it J is equal to 180. So 46 plus 90 is 136. Plus J. And I minus 136 from both sides, and I get J is equal to, you got it, 44 degrees. So all that work just to find this up here is 44 degrees because, yes, y is equal to 44. Also by corresponding angles are equal. Okay, highlight that. How'd you do? Okay, on this next one, I'm thinking trig. What do you think? Let's do the triangle sum on the interior angle first. 90 plus 22 plus y is equal to 180. This is just like the last one. So I'm getting 112 minus 112. What'd you get? Good job. And that's by triangle sum theorem. Okay, now that we have that up here is a 68, I could do Pythagorean, 3, 5, find the x, or I could do trig. You do you. I'm going to do Pythagorean. So 3 squared plus 5 squared equals the unknown hypotenuse squared. So 9 plus 25 is 34. So square root both sides. Please do it on your calculator right now so I know you know how to do it. 34, take the square root. I'm getting approximately 5.83, and this is U for units because it is a side length distance. Okay, so I did Pythagorean. Did you get the same thing with trig? Good for you. 2x plus 5 is equal to 113. Why? What do you know about those two angles? All right, 113 minus 5. I got that 108. 108 divided by 2, I got 54. Okay, what's the reason? Corresponding angles are equal. You got it. Ooh, saved by the bell. So I'm going to do another video for the downstairs proof there on this page. How'd you do on this upper part?